All right, in this video, this is going to be another kind of skill you're going to need in Unit 3, and that's called simplifying square roots. So we're going to look at a couple of examples, how to simplify a square root. We're going to look at square roots of negative numbers and how we write those, and those are going to be imaginary numbers. So kind of a couple of skills are going to be important to kind of help you through this unit. Okay. So for starters, if you had something simple like this, the square root of 81, that is a perfect square, so we shouldn't write it as the square root of 81. That's the number 9. And again, when you take a square root, you're trying to find what number times itself, or what number squared is what's underneath the square root. So the square root of 81 is just 9. Now, if you go through the solving piece, you'll realize like, oh, I'm supposed to have a plus or a minus. Yes, only when you're solving. So when we think about this as the square root of 81, we're really just talking about the positive one. Okay, the positive answer. If I wanted a negative one, I would have to have a negative out in front, which would then make this, negative 9 as our answer. Okay, so when we're talking about square roots, we're really just talking about the positive one. It's when you start solving that you're going to need a plus or minus in your answer. All right, so really what this video is going to be about is what do I do, how do I rewrite them when it's not a perfect square. So what if I had something like the square root of 120? 120 isn't a perfect square. There's not a number times itself. That is 120. 10 times 10 is 100. It's kind of close. 11 times 11 is 121. It just got just a little bit too big. So again, I know square root of 120 is somewhere between 10 and 11, but what I'm really trying to do is try to simplify it down. Okay? So how we simplify it down is sort of two ways. Option one is to search for perfect squares that divide into 120. Okay, so my perfect squares, when I think about them, there are 4. One's not going to do us any good. Okay, 1's a perfect square, so is 0. That's not going to help me kind of break this down. So 4 is a perfect square. The next one would be 9, 16, 25, 36, 49, 64, and on up the ladder. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. Okay, keep going with it. So what I want to do is I want to try to find one of these numbers, see if any of these numbers divide evenly into 120. And I want to try to find the biggest one I can, so it saves me some time. Well, 64 is more than double. If I double it, it's more than 120, so that one's out. 49 times 2 is 98, so not quite, that'd be too big. If I added another 49 onto it, so no there. 36, maybe, trying to think, 36 times 4. Well, 30 times 4 is 120, so that's too big. Times 3, that's an 18, so that's not working. And times 2, so I don't think that's gonna work for us. 25, no, that'd be 125. 16, so maybe 16. 5, 6. Not sure that's working for us. So I don't think 16 does. 9, nope, add the digits, it's not divisible. 9, so it really might be just down to 4. Okay. So 120, 4 is going to go in there 30 times. So I can rewrite this as the square root of 30 and the square root of 4. Okay. Well, the square root of 4 is 2. And if I think about the square root of 30, none of these go into 30. So 30, I can't simplify that down. So that's it. There's my answer. My answer is simply going to be 2 square roots of 30. Okay? And that's as good as I can do. So again, what I did is I found a perfect square that went into 120, which was 4, and it ended up being the biggest one. So I rewrote 120 as 30 times 4, both still underneath the square root. And then square root of 30 can't be simplified, but the square root of 4 does simplify to 2, so my final answer is 2 square roots of 30. Now, as you can kind of tell, that was sort of a thinking process. I had to try to figure out which one of these numbers divided in evenly. So there's kind of another method that works well, and that's using that factor tree idea. Okay? So if I use a factor tree, I can start just going, all right, 120, 2 goes into it. 2 times 60. Okay. And then 60, that can be broken down into 2 and 30. 30 can be broken down into 5 and 6, and 6 into 2 and 3. So really 120 is 2 times 2 times 5 times 2 times 3. Okay? Since this is a square root, what I want to look for is two numbers times themselves. What number is squared works in there. So I'm looking for pairs. And there's my pair of 2's. Okay? So once you find a pair, you kind of pull that pair out of the square root. This really was kind of like the square root of 2 squared. The square roots cancel. That leaves me with the 2. When I look at the rest of the numbers, 5, 2, and 3, none of them are pairs. Okay? So those guys all go back underneath. 5 times 2 times 3. And 5 times 2 times 3 is 10 times 3, or 30. So I get 2 square roots of 30. Okay? So this second method, using the factorization or the factor tree of it, I broke 120 into 2 and 60. Doesn't matter how you break it up. I could have done 4 and 30. Okay? Just depends on what you wanted to do. And then I broke 60 into 2 and 30, 30 into 5 and 6, 6 into 2 and 3. And I started searching for pairs because it was a square root. Okay? All right, so from there, pair comes outside of the square root, and anything that wasn't partnered up, didn't have a pair, you leave back underneath using multiplication. So there's your answer for that. All right, so let's look at another example, the square root of 54. Well, I know 9 goes into it. So I can break this into 9 and 6. 6, there's no perfect square that goes into it, and the square root of 9 is 3. So the first method, finding a perfect square that goes into it, 3 times the square root of 6. If I use the factor method, I might start off and go, yep, I know it's 9 and 6. 9 is 3 and 3. 6 is 2 and 3. Here's a pair, so the 3 comes outside, back inside, no partners, no pairs, 2 times 3. So you get 3 square roots of 6. Same answer, just a different way to do it. All right, a couple more. What if I have a square root of a negative? Okay. Now, square root of negative, we've always told you mathematically you can't do. Okay? And it's true, you really can't do. So somebody invented what are called imaginary numbers as a way to be able to take the square roots of negatives. Okay? And so what they invented is they invented this mathematical symbol called I for an imaginary number, and I is equivalent to the square root of negative 1. Okay? So one of the key things you want to know is that I equals the square root of negative 1. That means I squared, this is going to be an important piece, I squared would be taking I times I, or the square root of negative 1 times the square root of negative 1, or really kind of just squaring each piece here. Well, then the square root and the square cancel, so I squared is equal to negative 1. Okay? So these are a couple of key pieces for you, is that I equals the square root of negative 1, and I squared is negative 1. And that's going to help with some of the stuff you do in this unit as well. So how did I use that then? Well, first thing I would do is anytime you have a square root of a negative, rewrite it as I times the square root of that positive number. Because really what I'm doing is I'm rewriting this as the square root of negative 1 times the square root of 8. The square root of negative 1 we just defined as I. Okay. And now I'm left with the square root of 8. I'm going to do the same thing. Just break this one up. This one's kind of easy. Square root of 4 and the square root of 2. Square root of 4 is 2. I'm going to just kind of put that 2 out in front. So I have 2i times the square root of 2. Okay. So again, anytime you have a square root of a negative, you should have I in your answer. It's an imaginary number. Okay, you talk a little bit more about that in some of the later videos, the complex and imaginary numbers in this unit. All right, so last one we're going to look at is square root of negative 27. Again, I've got a square root of a negative, so I'm going to rewrite that as I times the square root of the positive. This time I'm going to break 27 up, use the other method just to kind of see some different examples. 27 is 9 times 3, 9 is 3 times 3. So there's a pair of 3's, so 3 is going to come outside the square root. I also have the I out there. And underneath the square root, this 3 didn't have a partner. So I get 3I square roots of 3. Okay. This is going to help you kind of simplifying the square roots. You'll see a little bit on the solving quadratics video. I didn't have any problems that had a square root of a negative in the end. Okay. But you should be able to solve this now when you solve problems. If they do have a square root of a negative, you're going to want to write it as I times the square root of the positive. So try to transfer this knowledge to some of those homework problems that might be on there.